Okay, so we're going to start out with a little bit of a recall of information. First, it says, what is the equation of the line for a linear parent function? Remember, our parent function is that equation for our linear that is not going to have any changes to the slope or to the y-intercept. So basically, it's the most basic linear function we can have. So it's the equation y is equal to x, or 1x, plus 0. So we don't have to put the 1, we don't have to put the plus 0. So our slope, that secret number in front of x, is 1. And there is no plus b out there on the end, so our b must be 0. Okay, so if this has not been moved up or down any, as we know, that means it must start here at the origin and go up 1 and over 1. So it looks something like this. That would mean it touches my x-axis, or has an x-intercept at the origin, 0, 0. And that would also be where it intersects my y-axis. So my y-intercept would also be 0, 0. And what it says below here is that changing the parameters, which is the slope and the y-intercept, or remember m and b, of the linear parent function is going to affect our graph in various ways. And it wants us to see how changing the slope changes the graph below. So it says, what would happen to the graph if we made the slope larger? And if you notice, it has our slopes increasing as we go from y1 to 2 to 3 to 4. All right, so I'm going to go put all of those in my graph. So it says in y1, we're supposed to put the function x. And then it says to put in y2, 2x. And in y3, 3x. And lastly, in y4, we're supposed to put in 6x. So everyone needs to type these in to y equals on their graphing calculator. And then we're going to hit graph and see what happens. So it's going to graph them in order, starting with y1 all the way to y4. All right, so the first line it graphed there was the blue line. Then it graphed the red line, and then the black line, and then finally the purple line. And if you notice, each one of those lines is a little bit steeper than the one before it. So I'm going to come over here and graph these. They already graphed what we would have seen in y1. Now I'm going to graph what I would see in y2. So it still starts at 0, 0, but instead of going up 1 over 1, a slope of 2 means to go up 2 and over 1. All right, so this is the graph that we would see for y2. And then we have y3 that says our slope is 3x. So now I'm going to go up 3 over 1. And as we can see, this one is even steeper than the one before it. Finally, y4 has a slope of 6x, which means to go up 6 and over 1. Which is even steeper than the one before it. So it would appear that the bigger that our slope is, that the steeper our line gets. So our conclusion is, as the slope increases, the line gets steeper. All right, so let's look at this next one. It says, what would happen to the graph if we make the slope smaller? So this time we start with that same parent function, but my slopes get continually smaller. So I'm going to go put these in my graphing calculator. So I still have y equals x in y1. In y2, we're supposed to have 1/2 x. So alpha y equals, enter, 1/2 x. In y3, we're supposed to have 1/3 x. So alpha y equals 1/3 x. And in y4, I'll put 1/6x. So in this particular case, we started with the blue line, then the red line, then the black line, and then the purple line. So here, instead of getting steeper, it seems to be getting flatter. If I came over here to graph these, we already have the parent function graphed. The next one still starts at 0, 0, but instead of going up 1/1, goes up 1 and over 2. So as you can see, this one does get a little bit flatter than the one before it. All right, the next function has a slope of 1/3, so it's going to go up 1 and over 3. As we can see, this one is even flatter than y2. And then finally, a slope of 1/6 means to go up 1 and over 6. Which is even flatter than the one before it. So here, it seems like as our slope is decreasing, our line is getting flatter or less steep. So as the slope decreases, the line becomes less steep. All right, and then finally, this one says, what would happen to your graph if the slope becomes a negative? And they tell us to, in our graphing calculator, in y1, to leave the parent function, and in y2, we should graph y equals -x. I'm going to clear out what I have in y3 and y4 and graph that. So again, the blue line is our parent function. The red line is y equals -x. So it appears these are the exact same line, they're just going in opposite directions. So it doesn't make the line any steeper or less steep. I just go up 1 and over 1 in the opposite direction. So this doesn't change anything about the steepness of the line. All it does is change the direction of the line. In other words, we could say the line changes direction, but the steepness is the same. Alright, so our summary here would be that our steepness is not affected by whether or not we have a positive or negative. It's affected by the number in front of x, which is what we call the slope. Or, remember in our equation, that's the letter m. We said a larger slope, like the first piece that we graphed, is going to cause our lines to become steeper, while a smaller slope, like the second picture we graphed, makes them less steep. And then as we discovered on our third graph, having a negative slope does not change the steepness. All it changes is the direction. Okay, so now that we know that, let's flip it over onto the back of our notes. And they have given us some equations, and we are supposed to identify which one is steeper. Remember, the steepness is determined by the slope, or m. If it's something big, it becomes steeper. If it's something small, it becomes less steep. All right, so for y1, my slope, remember, is the number in front of x, which is 4. And here, my slope is 6. Between 4 and 6, 6 is the larger number. Therefore, 6 means that y2 is going to be the steeper equation. All right, on the second row, my slope is -2, but remember the negative does not determine steepness, so all I'm worried about is the 2. The second equation doesn't have a number in front of x. We know that secret number is 1. Between the numbers 2 and 1, we know that 2 is the bigger number. Therefore, this time y1 is steeper. On the third row, my m, or my slope, in y1 is 2. And in y2, my slope is -2. But again, remember the negative isn't going to affect us here, so I ignore the negative, and I just look at the number 2. So in this particular case, the numbers themselves are the same. Therefore, one is not steeper than the other. These are the same. All right, and then lastly, here my slope is 1/2, and here my slope is 4/3. If we're unsure which one is bigger, we can always type those in our calculator to see. 1 divided by 2 is 0.5, and 4 divided by 3 is 1.3 repeating. Therefore, 4/3 is going to be larger, which makes y2 the steeper of the two equations. All right, number 2 says the original function is y equals 3/4 x minus 5 is going to be graphed on the same grid as the new function y equals 4/3 x minus 5. And they want to know which of the statements is true. Okay, so we start by graphing our b. So for my first equation, my b tells me I'm starting at -5. My slope here tells me I'm going up 3 and over 4. So it looks something like this. All right, and this was the original function. All right, the second one, it also has a b of -5. It just moved it down to the other end of the line there. But I am starting again at the exact same place. So I already have a point there. This time, my slope is 4/3. So here's the equation of the new function. So as we can see, the new is steeper than the original. A says the original is steeper. Well, that's not true, it's flatter. The graph of the original function is parallel. Remember, parallel means they run side by side and will never intersect. That's not the case here. They intersect at -5. Here, the graphs intersect at -5, 0. For D, they intersect at 0, -5. Remember, this is x and this is y. Our y-intercept is at -5, so this would be the coordinate point 0, -5. So that would be answer choice D. They do have the same y-intercepts. All right, number 3 says, if the slope of the original function is negative 4.5 plus 3.2, is changed to 1.5. So it says you're going to change your slope, which is the m value. Which of the following is true? So since this slope is a decimal, we might want to graph these in our graphing calculator. So the original function, they said, was negative 4.5x plus 3.2. And they said the new equation is going to have its slope changed to 1.5x, but not change the y-intercept, so it still stays as 3.2. And I'm going to graph those. All right, so this is what they would look like. Our answer choices say the graph of the new function intercepts the y-axis at the same point as the original. Well, if I look here, they do intersect my y-axis at the exact same point. So that is true. So that one sounds good so far. B says the graph of the new function intersects the x-axis. They do not intersect the x-axis at the same spot, so that can't be it. C says the graph of the new function has a negative slope. No, the new function is the one in red, which is a positive slope. And D says the graph of the new function has a positive x-intercept. Again, the new function is the one in red. It touches the x-axis over here around -2. So that would be incorrect as well. So it would be answer choice A. All right, and then the last question says, which best describes the effect on the graph of -3x plus 7 if the y-intercept is changed to -5. So here's the original function. They said that it's going to stay the same, except I'm going to change the y-intercept to -5. So I'm going to graph these both over here on my coordinate grid. So the original one started at +7 and has a slope of -3. Remember, that's the same as -3 over 1. So I go down 3 and over 1 to the right in that negative direction. All right, so here is the original, while this is my new. So it starts at -5 and also goes down 3 and over 1 in that negative direction. All right, so answer choice A said the slope decreased. Well, our slope was -3 both times, so no, the slope stayed the same. B says the new line passes through the origin. Well, our origin is right here, and neither one of those seem to pass through there. C said the x-intercept increased. Well, the new one is over here, which is going to have a negative x-intercept, while originally it had a positive x-intercept, so it can't be that. Then D said the y-intercept decreased. So on the original, my y-intercept was up here at +7, and now it's down here at -5. If I went from 7 down to -5, that would be a decrease.